All right, next two properties are the multiplication and division property. So multiplication, you're increasing by the common number. Okay, so if AB equals CD, then if I double the left, then I need to double the right. For division is if I start with the same segments, AB and CD, and if I cut one in half, then I have to cut the other in half for them to maintain the same amount. So it says that if MP, I'm just going to add P here, and I'm going to add S here. So if MP is congruent to NS, so this is congruent to this. O is the midpoint of MP, so I see a vocabulary word. So as I'm thinking, as the wheels are turning in my head, let me get some lines down for my proof. So statement 1 is what I have in the given. Reason 1 is my given. I see my vocabulary word of midpoint. So right away, that needs to be my next reason. I need to write definition of midpoint. And what does that tell me? Well, if O is the midpoint, then I know that MO and PO are congruent. And if R is the midpoint, then I know that NR and SR are congruent to each other. And again, I can include those in the same line because they have the same reason. If you choose to split it up, that is fine, but you do not need to. And then for line 3, so it says, we're trying to prove that MO and NR are congruent. Well, if originally the bigger segments were the same, and each one is now split into 2 equal parts, then we're cutting something in equal amounts. This is our division property, so we can say that MO is then congruent to NR. And not only is it congruent to those two, but it's also congruent to OP and RS. But that's not what is in our proof statement, so we only have to include what is in the proof statement for that final statement there, for that. All right, so again, I'm hoping you're writing all this stuff down. I would even try to write the problems down first and then try them maybe on your own before you see me go over them, especially with proofs because this is a new concept for many of us, if not all of us, and it's definitely something that's going to take a little bit of practice understanding here. All right, so example 2 says we have a lot of information here. So I would even just right off the bat, just right ahead, go and copy it down. So NOP is congruent to RPO. So again, I got cut off here. So R's up at the top here. P must be down here. PT bisect. So again, you're seeing a vocabulary word. What's being bisected? An angle. So that's why I have my reason 2 here. So when an angle is bisected, it splits it in half. So if PT bisects RPO, so then I know, where are we here? This guy is congruent to this guy. And if I have the same on the other side, I know that this is congruent to this by the other bisect, because OS bisects that angle. Okay, so I used my notion. Now what's being bisected? An angle. So that is why it doesn't just say definition bisect, it says definition angle bisector. And I include both of those statements there for the angles that are being bisected. So if originally we were told the larger angles were congruent, which actually I have this drawn wrong, so this is congruent to this. Just like we had on the statement in the previous example, if the larger angles are congruent and each one is split into equal parts, then by the division property, we can say the smaller pieces are congruent. So angle 1 is congruent to angle 3, and to be honest, if you want to include angle SOP and angle TPO, you can include those two as well, but all 4 of those smaller pieces are then congruent. So the greens and the reds are all equal to each other. Now the last piece comes in. We're talking about NSO and RTP being congruent. Well, those come into play right here. So here's NSO and here's RTP. In line 3, we just showed that angle 1 and 3 were congruent to each other. So that means this is equal to this. So if you have 2 angles that are complementary to congruent angles, then you know that those 2 yellow angles are equal to each other. And that is your proof statement, which is the final line. So again, I'm going to write this reason out a little bit lengthier. So if two angles are complementary to two congruent angles, then they are congruent to each other. Okay? So please, again, it's so important that we review these ideas, proofs especially. The last thing though, I tried to just summarize the multiplication and division just so you know when to use it because a lot of times multiplication gets confused with addition and division gets so confused with subtraction. So things you're looking for the double use of the word midpoint, trisect, or bisect. Those are key. So those are the three words: midpoint, trisect, and bisect, because that means splitting into equal parts. For the multiplication property, in addition to number one, you have to have number one. You are looking for when a segment or angle in the conclusion, which is your proof statement, if they are bigger than those that you're starting with. So basically, what you have in your given is smaller than what you're ending up with. So you're getting bigger over time. So if you have number two in combination with the word midpoint, trisect, and bisect, then it's multiplication. If you have number one in combination with the fact that your conclusion or your proof statement is smaller than that in the given, then that is your division. If you do not have any reference to the words midpoint, trisect, or bisect, but you have still the idea in number two